Hello, my dear students and the rest of the learners. Welcome to this presentation in which we are going to discuss on the topic Introduction to Computer Programming, with this being part one of a two-part series of presentations in this topic. My name is Meme JM, or you can simply call me Emily Swap. In this presentation, we are going to discuss the definition of terms used in programming, the history of programming, the programming languages and their generations, the advantages and disadvantages of programming languages, and then we shall lastly look at the approaches or paradigms to programming. Let's commence by looking at the definition of programming. Programming is the process of developing computer instructions using a particular programming language in order to solve a particular problem. Therefore, the purpose of computer programming is to solve the user's needs, that is, developing instructions for the computer with the aim of solving a particular user problem. This enables the computer to accept and manipulate data as well as print results automatically. A programmer is therefore a specialist whose main work is to develop computer instructions using a particular programming language in order to solve a particular problem based on the user's needs. On the other hand, a programming language is a set of instructions that are used by a computer programmer for writing computer programs that can be translated into machine-readable form by the computer. So, just as humans understand a variety of spoken languages, for example, English, Spanish, French, etc., computers also recognize a variety of programming languages. And therefore, when any programmer wants to solve a problem by developing a computer program, he or she has to make use of a programming language that he or she understands best, or that he or she is an expert at and in. Computer programming languages, therefore, allow us to tell machines what to do and how to do it. A computer program is therefore said to be a set of coded instructions for the computer to obey and process data. So, what is the history of programming? Where did we start from? And where are we currently? The history of programming focuses on some of the languages that have been being developed over the years, culminating to the languages that we have today in the market. I will later on focus on the generations of the programming languages, or how we categorize the programming languages based on the years when they were developed and their main characteristics. So, when it comes to the history of programming languages or programming, this is where we began, whereby in the year 1800, Joseph Marie Jacquard taught Loom on how to read punch-cards, thus creating the first heavily multi-threaded processing unit. And therefore we can say that Joseph Marie Jacquard was the first person to develop a computer program in the year 1800. Then in the year 1842, a lady called Ada of Lovelace, or Ada Lovelace, scribbled in a notebook what would later come to be known as the first published computer program. And that's why we say that Ada Lovelace was the first computer programmer, because she wrote her first computer program by scribbling it in a notebook. And then in the year 1883, an algorithm for the analytical engine was developed. It was created still by the same lady who is called Ada Lovelace for Charles Babbage's analytical engine that Charles Babbage had left having recorded and described in his book. So, Ada of Lovelace wrote the algorithm that would be used in the analytical engine for Charles Babbage to compute what we call the Bernoulli numbers. And therefore, this was considered to be the first computer programming language. In the year 1936, Alan Turing invented everything. The British courts do not approve and have him chemically castrated, or the British courts had him chemically castrated. But in the year 1949, we had what we call the assembly language. This was the first widely used language in the electronic delay storage automatic calculator assembly language. So this language was a type of low-level computer programming language that is simplifying the language of machine code, whose specific instructions needed to tell the computer what to do. In other words, it was in 1949 when the first assembly language was developed, and it was first used in a device that is called the electronic delay storage automatic calculator. Then in 1952, AutoCode was developed. AutoCode was a generic term for a family of early computer programming languages. The first was developed by Alec Glenier for the Mark I computer at the University of Manchester in the United Kingdom. Some consider AutoCode to be the first compiled computer programming language, meaning that it could be translated directly into machine code using a program that was called a compiler. Then in the year 1957, Fortran programming language was created by John Backus for complicated scientific, mathematical, and statistical work. And therefore, Fortran stood for formula translation. It is one of the oldest computer programming languages that is still used today in certain sections of the society, and more so by certain programmers. In 1958, ALGO was developed. It was created by a committee for scientific use, and it stands for algorithmic language. In other words, ALGO is a short form for algorithmic language. ALGO, algorithmic language, algorithmic or algorithmic language. ALGO served as a starting point in the development of other languages such as Pascal, C, C++, and Java. In 1959, another language by the name COBOL was created by Dr. Grace Murray Hopper as a computer programming language that would run on all brands and types of computers. COBOL is an acronym which stands for Common Core Business Oriented or Language. And therefore, COBOL stands for Common Business Oriented Language. It is used in automatic teller machines or ATMs, credit card processing, telephone systems, hospital and government computers, automatic systems, and traffic signals. In the movie The Terminator, pieces of COBOL source code were used in the Terminator's vision display. In the same year, 1959, another language called Lisp was created by John McCarthy of MIT. Lisp is still in use, and it stands for Least Processing Language. Least Processing Language. It was originally created for artificial intelligence research, but today it can also be used in situations where Ruby or Python are used. In 1964, BASIC language was developed. It was developed by John G. Kemeny and Thomas E. Coase at Dartmouth College, so that the students who did not have a strong technical or mathematical understanding could still use computers. And it stands for beginners or purpose symbolic instruction code. A modified version of BASIC was written by Bill Gates and Paul Allen. This was to become the first Microsoft product. In 1970, Pascal programming language was developed by Nicholas Wirth. It was named in honor of the French mathematician or physicist and philosopher Blaise Pascal. It is easy to learn and was originally created as a tool for teaching computer programming language, and it is still used today in teaching certain subjects such as structured programming languages or units. Pascal was the main language used for software development in Apple's early years. In 1972, Smalltalk was developed by Alan Kay, Andele Goldberg, and Dan Eagles at the Xerox Palo Alto Research Center, and Smalltalk allowed computer programmers to modify code on the fly and also introduced other aspects now present in common computer programming languages, including Python, Java, and Ruby. In the same year, 1972, C was developed by Dennis Ritchie at the Bell Labs. C is considered by many to be the first high-level programming language. A high-level computer programming language is closer to human language and more removed from the machine code. C was created so that an operating system, which is called Unix, could be used on many different types of computers. It has influenced many other languages, including Ruby, C#, Go, Java, JavaScript, Perl, PHP, and Python. In 1972, again, another language that we call SQL was developed. It was developed by Donald D. Chamberlain and Raymond F. Boyce at IBM, that is International Business Machines. The SQL stands for Structured Query Language. It is used for viewing and changing information that is stored in databases. SQL uses command sentences that are called queries in order to add, remove, or view data. In 1978, MATLAB was developed by Cleve Muller. MATLAB stands for Matrix Laboratory. It is one of the best computer programming languages for writing mathematical programs and is mainly used in mathematics, research, and education. It can also be used to create 2- and 3-dimensional graphics. In 1983, Objective-C, or OC, was created by Brad Cox and Tom Love. Objective-C is the main computer programming language used when writing software for Macintosh operating systems or Mac OS and iOS, Apple's operating systems. In 1983 again, C++ was developed by Barney Stroustrup. It is an extension, or it was an extension of the C language. It is one of the most widely used languages in the world today. C++ is used in game engines and high-performance software like Adobe Photoshop. Most packaged software is still written in C++. In 1987, Perl was developed. Perl was originally developed by Larry Wall in 1987 as a scripting language designed for text editing. Its purpose was to make report processing easier. It is now widely used for many purposes, including Linux system administration, web development, and network programming. In 1990, Haskell was developed. It was named after Haskell Brooks Carey, an American logician and mathematician. Haskell is called a purely functional computer programming language, which basically means that it is mostly mathematical. It is used by many industries, especially those that deal with complicated calculations, recons, and number crunching. In 1991, Python was developed. It was designed by Guido van Rossum, and it is easy to read and requires few lines of code than many other computer programming languages. It was named after the British command group, Monty Python. It is used in popular sites like Instagram, use frameworks that are written in Python. In 1991, again, Visual Basic or VB was developed by Microsoft. The Visual Basic allows programmers to choose and change pre-selected chunks of code in a drag and drop fashion through a graphical user interface. In 1993, a language called R was developed by Ross Ihaka and Robert Gentleman at the University of Auckland, New Zealand. R is named after the first names of the first two authors. It is mostly used by statisticians and those performing different types of data analysis. In 1995, Java was developed. It was originally called Oak, and it was developed by Sun Microsystems. It was intended for cable boxes and handheld devices, but was later enhanced so that it could be used to deliver information on the World Wide Web. Java is everywhere, from computers to smartphones to parking meters, etc. Currently, over 3 billion devices run on Java. In 1995, PHP was created by Rasmus Landorf, and it was used and even used today for most web development and is usually run on web servers. It originally stood for personal homepage, as it was used by Landorf to manage his own online information. PHP is now widely used to build websites and blogs. WordPress, a popular website creation tool, is written using PHP. In the same year, 1995, Ruby was created by Akiro Matsumoto, who combined parts of his favorite languages to form a new general-purpose computer programming language that can perform many programming tasks. It is popular in web application development. The Ruby code executes more slowly, but it allows for computer programmers to quickly put it together and run a program. In 1995, again, JavaScript was created in just 10 days by Brendan Eich. This language is mostly used to enhance many web browser interactions. Almost every major website uses JavaScript. Then in the year 1986, James Gosling invented the first truly overly verbose object-oriented programming language where design patterns rule supreme over pragmatism. In the year 2000, C# was developed by Microsoft with the goal of combining the computing ability of C++ with the simplicity of Visual Basic. C# is therefore based on C++ and is similar to Java in many aspects. It is used in almost all Microsoft products and is primarily used for developing desktop applications. Then in the year 2001, Anders Hallsberg reinvented Java and called it C# because programming in C feels cooler than Java. In the year 2003, Scala was created by Martin Ondaatje. Scala is a computer programming language that combines functional programming, which is mathematical, with object-oriented programming, which is organized around data that controls access to code. Its compatibility with Java makes it helpful in Android development. In the year 2003, Groovy, developed by James Strachan and Bob McWhirter, was derived from Java, and it became an improvement because it improves the productivity of developers, for it is easy to learn and it's concise. In the year 2005, David Hansen created a web framework called Ruby or Ruby on Rails, and therefore people no longer remember that the two are separate things. In the year 2009, another language called Go was developed by Google to address problems that can occur in large software systems. Since computer and technology use is much different today than it was when languages such as C++, Java, and Python were introduced and put to use, problems arose when huge computer systems became common. Go was invented to improve the working environment for programmers so that they could write, read, and maintain large software systems more efficiently. In the year 2013, Jeremy Ashkenaz wanted to be happy like Ruby developers, and therefore he created what he calls CoffeeScript, which compiles to be JavaScript, but looks more like Ruby. In the year 2014, Swift was developed by Apple as a replacement for C, C++, and Objective-C. It was supposed to be easier to use and allow less room for mistakes. It is versatile and can be used for desktop and mobile apps and cloud services. Chris Lattner made Swift with the primary design goal of not being Objective-C in the end, because it looks like Java. Having looked at those developments in various languages, let's now see how we categorize or generalize programming languages based on their generations, or how we classify the programming languages based on their generations or evolutions. The programming languages, as we have seen, have evolved through various generations and mostly 5 main generations, from the first generation to the 5th generation. The first and second generations were composed of programming languages that are classified as low-level languages, while the third to 5th generation languages are classified as high-level languages. Let's look at the low-level languages. These are programs that are almost directly understood by the computer because they require very little or no conversion at all into computer understandable form. A program is called low-level when it is closer to the language that the computer itself uses. These programs are hardware-oriented, and thus each program is coded to be used only by a specific computer. The two categories or generations of these languages are the machine languages, or what we call the first generation languages, and the assembly languages, or what we call the second generation of programming languages. Machine languages, or first generation languages, are a set of instructions or programs were written in the form of zeros and ones, forming what we call the binary codes. Therefore, machine language instructions use a series of binary digits, ones and zeros, that correspond to the on and off electrical states of a computer. It is the only language that the computer can understand directly because all the instructions and data are in the form of binary, therefore forming object code. An object code is a sequence of instructions that have been written or coded in machine readable form, that is in form of zeros and ones, or what we call the bits. Therefore, an object code program is a set of instructions that have been coded in binary form that the computer can read and understand without any further translation. The advantages and disadvantages of machine languages include the following. Some of the advantages are, number one, the instructions written using this language are executed very fast because no translation is required. Secondly, there is efficient use of the central processing unit, as these instructions do not occupy large memory space. However, some of its disadvantages include, number one, both data and instructions are expressed in binary digits or bits, hence becoming difficult to differentiate unless with the use of a reference manual. Secondly, the programs are lengthy and time-consuming when being coded. Thirdly, is that the programs are machine-dependent, hence difficulty to be executed by different machines. Fourthly, is that these programs are error-prone. In other words, it is very easy for a programmer to make a mistake when coding because a wrong inclusion of a 1 or a 0 can change the whole meaning of the program. Fifth is that programming becomes more difficult and tedious as the complexity of the program increases. Let's now look at the assembly languages, or what we call the second generation programming languages. In order to express operations more abstractly and reduce the difficulties in writing machine language programs, assembly languages were developed. These are programming languages in which data elements, operation codes or instructions, and the storage locations are represented as a set of symbolic operation codes called mnemonics, shortened 2 or 3 letter ones. In other words, mnemonics are shortened 2 or 3 letter ones or characters. The programs written in assembly language must be translated into machine code before execution using a translator that we call an assembler. A translator is a language processor or a computer program that converts the source program into object code. So it converts statements that have been written in one language, that is assembly language, to statements in another language, which is usually the machine language. A source program or code is a set of instructions that a programmer writes using a particular programming language that must be translated into machine readable form for the computer to be able to understand. Its main advantages, or the main advantages of the assembly language or second generation languages include: number one, alphabetic abbreviations or mnemonics are easier to remember than purely zeros and ones. Number two, it is readable both by man and machine. Number three, it is concise with a few instructions, thus being easier to code than machine language. One of its main disadvantages is that it must be translated by an assembler into machine language before execution, and therefore it takes longer time to be executed as compared to machine language or as compared to first generation languages. The other category of programming languages are the high-level languages. These are programming languages that allow a programmer to code instructions in a language that resembles that of human beings. A program is normally called high-level when it's closer to the language that humans use. It can be read and understood even by people who are not experts in programming. Examples of high-level programming languages include BASIC, C, C++, COBOL, Java, Fortran, Anda, and Pascal. And my dear students and the rest of the learners, I believe that you remember what I have said just now concerning the years when each of these programming languages were developed, and the developers, as well as the intention for those programmers to develop these languages. Syntax is the structure of a sentence and the grammatical rules governing the way in which instructions are written using a certain programming languages. In other words, as a programmer, you can be able to tell which programming language has been used to code instructions, because each language or each programming language has its own outstanding syntax. And if you include the syntax for another language in the language that you are making use of, that program that you have written will be treated as having errors. Syntax is normally in terms of punctuation, vocabulary, and grammatical rules. Semantics, on the other hand, is the meaning of words and the sentences in a certain programming language. So if a word is used or is shared among us various languages, its meaning in each of the language may be different from the other. A program coded using a high-level programming language must first be converted into machine language, or what we call the object code, before execution using a translator that can either be a compiler or an interpreter. My dear students and the rest of the learners, up to this point, I believe that now you have known of 3 types of translators: the assembler, the compiler, and now an interpreter. A compiler is a special program that processes the entire source code written by a programmer using a high-level programming language into object code that a computer's processor uses. A linker, on the other hand, is a program that allows you to link 2 or more programs that have been developed separately and make them run smoothly. An interpreter is a program that converts a source program into an object code line by line. The 3 categories or generations of these programming languages are the 3rd generation languages, 4th generation languages, and the 5th generation languages. Let's look at the 3rd generation languages. These are programming languages that made it possible to break down a program into modules and subroutines, what we call subprograms, thus being flexible, easier to read and modify. A module is a portion of the main program or groups of processing instructions within the main program. 4th generation languages. These are programming languages that frees the programmer from the tedious work of writing lines of code through the use of controls and application generators. The 5th generation languages. These are programming languages that are created to make the computer to solve the problem of the programmer by the computer depicting human-like intelligence, thus helping the programmer not to spend a lot of time to come up with a solution, but only worry of the problem to be solved and the conditions to be met. My dear students and the rest of the learners, it is important to note that the 5th generation languages are the languages that are in place even today. They are designed to make the computer solve the problem for you because all codes for the program are automatically generated. It is important for me to note, or for you to note, that whereas we have various generations of languages, it doesn't mean that because today we are having 5th generation languages being developed, that the previous generation of languages have been done away with. It depends with what programmers want to do. And therefore, whereas we are in the 5th generation languages or era of 5th generation languages, and towards transition to 16th generation languages, we are still having programs in the previous generations being applied in certain quarters of the society. Let's now look or focus on the advantages and the disadvantages of the high-level programming languages. So, some of the advantages of high-level languages include: number one, they permit faster development of large programs, for they require less time to code. Number two, they are portable. That is, they are not machine dependent, meaning that a single program written using a certain computer can still be installed and applied in many other different computers. Number three, they are user-friendly and easy to use and learn. Number four, they are more flexible. Hence, they enhance the creativity of the programmer and increase productivity in the workplace. Number five, they are far much easier to correct errors or debug. Number six, one doesn't need to know how the machine is to translate the programs to be executed by it. Number seven, they provide better documentation. On the side of disadvantages, number one is that the high-level programming languages require one to have knowledge of the programming language that he or she is going to use. Number two, if wrong data is keyed into them, they generate wrong information. Number three, a programming language may not notice logical errors in the program. Number four, the complexity of the instructions causes slower program processing. Number five, they have to be interpreted or compiled to machine-readable form before the computer can execute them. Number six, their nature encourages use of many instructions in a word or a statement. Hence, the complexity of these instructions causes slower program processing. Number seven, they require larger CPU storage capacity for compilation. Let's now focus on the approaches or some paradigms to programming. When we talk about the approach or a paradigm, we are talking about the methods or ways that programmers use in solving a problem using a programming language. These methods include, or these paradigms include, number one, structural programming paradigm, the modular paradigm, the top-down paradigm, bottom-up paradigm, object-oriented programming paradigm, amongst the others. Let's look at structured programming paradigm. It is a programming approach in which the code instructions are executed one after another in a serial manner until the entire program execution process completes. The languages that support structured programming approach or paradigm include C, C++, Java, C#, amongst the others. Even Pascal is included in this category. The program in this context is divided into several basic structures called building blocks, such as number one, sequence structure, which is a very simple module of structured programming whereby statements are just executed in the order in which they have been written without evaluation of any conditions and without skipping any action in the sequence. The following is an example of how this structure works. If, for example, you develop or you want to write a program for adding numbers, you just write the first statement. The statement is executed. So you write the first statement, for example, enter first number. The second statement is, for example, enter second number. Then that statement will be add the first number to the second number. And then fourth statement would be display the results. So when those instructions are executed in that order, from first statement, second statement, third statement, and the fourth statement in the exact order that they are, without skipping any of the statements, then we say that that is a sequence structure. The second type of structure is selection or conditional structure. This is a module that provides a decision point which allows certain choices to be made or certain actions to be taken depending on a condition that has been met. Therefore, execution of statements depends on a condition that returns true or false. So, selection is a control structure in which a number of processing options are presented and an option chosen for execution depending on a condition that returns true or false. So, an example to illustrate how this works is, for example, if you want to add numbers, but then, or you want to add numbers or subtract numbers, you want to perform either an addition or a subtraction to the numbers entered based on their size. You can do it, for example, as follows. If, for example, you want to add numbers that are smaller than 5, add numbers that are smaller than 5, and subtract numbers that are bigger than 5, then you can, for example, have statements in the following order. First statement, enter the first number. Second statement, enter the second number. That statement is check if the number entered, the first number, check if the first number is less than 5 or more than 5, such that if the first number entered is less than 5, then add the first number to the second number. Else, if you find out, or else if the first number is greater than 5, then subtract the second number from the first number. And then the fourth statement is display the results. My dear students and the rest of the learners, if you have listened to me carefully, you have noticed, or you must have noticed, that statement number 3 is to check if the number, the first number, is less than 5 or more than 5, such that if the first number is less than 5, then an addition operation takes place. But if the first number is more than 5, then the second operation, which is subtraction, takes place. So at any given situation, one of the operations will take place, either addition or subtraction, but no time when the addition statement and the subtraction statement will take place at the same time. The third structure is called repetition or iterative structure. This is a control structure which is used in a situation whereby an instruction or a group of instructions are to be executed again and again, that is repeated, until a certain condition is fulfilled without the programmer having to record them. So a number of statements are repeated until a condition is met, that we call that conditional looping, or for a specified number of times, which we call unconditional looping. When a group of statements or instructions are repeated, it is called a loop. The two means of repetition are either computer or counter, are either counter-controlled repetition or sentinel-controlled repetition, whereby the counter-controlled repetition is also called definite repetition, because the programmer knows in advance exactly how many times the loop will be executed. For example, if you have a situation where you want to enter or compute marks for 50 students, it means that you already know that you are going to repeat computation for students from the first one to the 50th one. And therefore, the control variable in this case will be the number of repetitions, which is 50. So you know in advance that you are going to compute marks for 50 students. And therefore, the repetition or the computation will repeat. From the first computation, you move on to the second student, the third student up to the 50th. And the computation or the program will terminate when the 50th student's marks are being computed. And therefore, you are supposed to inform the computer or the compiler or the interpreter in advance how many times the repetition takes place. So maybe the first statement would read like, how many students do you want to compute marks for? The person enters 50, and therefore the program will repeat 50 times. The other one is sentinel controlled repetition. This is sometimes called indefinite repetition because it is not known in advance how many times the loop will be executed. So in this case, sentinel values are used to control repetition. For example, if you don't know how many students you are going to compute results for in advance, you want to compute as many students as possible results. In this case, you can include a statement that prompts the person or prompts you to state whether you want to continue with the computation or not. So after you have computed, for example, the first student's results or marks, after you have written a program for computing the student's marks or a student marks, when you are through with the first set of statements, The last statement can read as follows. Do you want to compute another student's marks? Yes or no? If a person chooses yes, the first initial statement or the first statement that was executed in computing the first student's marks will be executed afresh. So the first, second, third statements in that order for computing the first student's marks will be repeated second round. Then when the next statement or the statement is encountered again, do you want to compute another student's marks? Somebody chooses yes. The execution of the previous statements is repeated second time. And that can continue as long as the person enters yes or chooses yes option. But once a person chooses no, when asked, do you want to compute another student's marks? If somebody chooses no, then the program terminates. So that's what we call iterative structure, which is sentinel controlled. The other programming paradigm is what we call the modular programming paradigm. So what is modular programming paradigm? Modular programming is a programming technique that enables large programs to be broken down into modules that perform a particular task using simple control structures in problem solving, and then these modules are incorporated into the main program through interfaces. So this programming style entails identifying sequences of code that perform discrete tasks and segregating them into independent units called subprograms or subroutines. The third approach is called top-down approach. In this approach, a large program is continuously decomposed to the smallest size modules from top to bottom. Therefore, the program is first subdivided into submodules, and then submodules are further subdivided into submodules, and this process continues up to the smallest submodules. In other words, up to the lowest level in the program. The fourth paradigm is called the bottom-up approach. In this approach, the programmer starts by coding the smallest submodules first, and then continuously combines them, forming larger modules, and the larger modules are linked together, forming a larger program. In other words, the programmer begins by developing the very lowest levels modules, or the very lowest level modules for a program or for a big program. And then these submodules are combined as he or she moves upwards in the hierarchy of the system, up to the time when he or she is able to complete forming the larger program. An example is, for example, if you want to develop a system for a large organization, a system that caters for different functions or that performs various activities, such as admitting students, examining students. In this case, you can begin by developing a subprogram or a module for admitting students. Once that module is over, you move on to the next module on evaluating students or assessments. And then once the two modules have been successfully created or developed, they can then be put together or connected together or combined together to form a system for the institution that can be used to both admit and assess or evaluate the students. So when you begin by creating sub-programs or modules for performing certain tasks, and then you combine them as you move upwards towards having a common program or system or a big program that can be able to perform various tasks, then we say that that is what we call performing or making use of bottom-up approach. The reverse is correct. For top-down, you begin by developing the overall program, and then you move towards the specific sub-programs. So even if a new activity is added, you just move downwards in that big program, that large program for the organization. You move down and add to it a link to the new module, and then you move on and develop the code for that module, etc. So that is top-down. So top-down is the opposite of bottom-up approach. Therefore, designing a program is started from bottom and advanced stepwise to the top. It is the opposite of top-down approach, just as I have said. The other paradigm is the object-oriented programming paradigm. This is a special type of programming approach in which a program is organized into objects, with each object containing both the data and the processing operations necessary to perform a task, and all program activities are centered around the objects. This approach encourages the programmer to place data where it is not directly accessible by the rest of the program, but instead, the data is accessed by calling specially written functions that we call methods, which are either bundled in with the data or inherited from class objects. These functions act as intermediaries for retrieving or modifying the data that they control. Generally, all the various programming approaches or paradigms can be classified into two. Number one is imperative programming, which focuses on how to execute defined control flow as statements that change a program state. Number two is declarative programming or declarative programming. It focuses on what to execute, defines program logic, but not detailed control flow. And with that, we have come to the end of part one of my presentation in this topic. Congratulations for learning part one of two in Introduction to Computer Programming topic. You can now access part two of the topic as well as other computer or ICT videos by clicking or tapping on Emily Swap ICT YouTube channel below this video. You can also visit Emily Swap Life Skills YouTube channel for free life skills, motivational, and inspirational resources. You can subscribe to their channel by tapping on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write to us through the email emilyswap@gmail.com. Thank you very much for listening to me, and God bless.